Day 2, multiplying numbers in scientific notation. So they want us to multiply 5.78 times 10 to the fifth power multiplied by 0.0804. So again, like we've been doing, we're going to go ahead and change the factor that's written in standard form into scientific notation. So we'll go ahead and do that. And remember, our coefficient needs to be a number between 0 and 1. So I'm going to go ahead and place my decimal point behind my 8. So now I have 8.04 times 10 to the something. In order to get from 8.04 back to our 0.0804, I need to move my decimal place 2 times to the left. I moved it to the left, so I know that's a negative, and I moved it 2 times. So my exponent should be -2. And that's where they got this here in the solvent. All right, so now that we have that, we can, since we're multiplying everything, we can go ahead and move or regroup. So we can put our coefficients together, and I'll highlight those in green. And we can also multiply our powers of 10 together. All right, so we'll end up doing 5.78 times 8.04 multiplied by 10 to the fifth power times 10 to the negative second power, and we'll find our answer. All right, so we will first do 5.08 times 0.8, times 8.05. Oops. So let me go ahead and do that. I'll just go ahead and do it on here so you have it on your paper as well. 5.78 times 8.04. I don't know why I keep saying it wrong. All right, so let's go ahead and solve that. Oops. Okay. And then we have, I don't want to get confused. So then I have my 4 and my 6. 6. And I have 4 digits behind my decimal. So there we go. We have 46.4712 times 10 to the something. And then this is just my product rule here. 10 to the fifth power times 10 to the negative second power. Product rule says if you have two numbers being multiplied together, they have the same base. Keep the base the same, add the exponents. 5 plus -2 is equal to 3, so it's 10 to the third power. And since, of course, we know that we more than likely need to write this in scientific notation, or yes, in scientific notation. But in order to make sure you do it correctly, you can always just go back to standard form to see what the actual answer will be. And that means we're just going to move our decimal place 3 places to the right. 1, 2, 3. So it'll be after the 1. Oops. I don't know what I'm writing. 471.2. All right, and I need to write that in scientific notation, so my coefficient should be a number between 1 and 10. And then I just need to see, well, how many times have I moved my decimal place to get, or how many times do I need to move my decimal place to get back to my original? So it's 1, 2, 3, 4 times. So now I have my final answer. All right, so my answer is 4.6471.712 times 10 to the fourth power. And that should be your solution as well. All right, and let's go ahead and go through the connected. Number 9, complete the equation by applying the associative property to group the decimals and to group the powers of 10. So we're just regrouping. That's what associative property is telling us to do. Put that on your paper. That means that we're regrouping. All right, and again, I've already done that on this page, so I'm just not gonna, I wrote it pretty big over there. So I'll put my coefficients together. 5.78 times 8.04 times 10 to the 5th power times 10 to the negative 2nd power. Number 10, multiply the decimals and multiply the powers of 10. When I multiply my decimals, I got 46.4712, and I'll just copy that. Write that a little smaller. Okay, it's fine. So I got that, and I got 10 to the 3rd power. All right. Oh, that's what they meant. Oh, and then of course I'll just put them together here. 4712 times 10 to the 3rd power. Apply the properties of exponents to write your solution in scientific notation. So then all you would do is, since we are trying to get here, we needed to add another digit behind our decimal in order to get back here. So then we just add 1 to our exponent. And again, we've already done that over here. So you can see what it was supposed to be in standard form. So this is our answer, or our solution, in standard form, and we put it back in scientific notation to prove it. All right, look at estimated on the previous page. Is your solution reasonable? So the estimation, they had 5.78 times 10 to the 5th power. They estimated or rounded it up. 5.78, they rounded it to 6. And then times 0.08. So they just multiplied 6 times 10 to the 5th times 0.8. And so they did 6 times 0.08, and they got 0.48 times 10 to the 5th power, and they got 4.8 times 10 to the 4th. Our final solution was 4.64712 times 10 to the 4th. So the 10 to the 4ths are exactly the same, and 4.8 is very close to 4.64712. So yes, our estimate is reasonable. Our estimate is very close to our solution, so our solution is reasonable. Yes. All right. Number 3, why is it unnecessary to make the exponents the same before multiplying numbers expressed in scientific notation? Well, it's unnecessary because if you did that, you'd have to end up simplifying it anyway at the end. It really doesn't make any sense. That's almost like saying, if I was multiplying 2 fractions together, that I would need a common factor first. You don't need that, because again, what you'd have to do at the end is simplify once you're done. So it just doesn't make any sense to do that, because you'll just end up having to simplify at the end. To get your product back to scientific notation. Okay. And now finally for day 3, the try it. The world's thinnest computer chip is 7.5 times 10 to the negative 3rd millimeters thick. What would be the height of a stack of 3 times 10 to the 9th chips? If one of them is 7.5 times 10 to the 3rd, to the negative 3rd, and you have the height of this, so all you would need to do if the stack is here, all you need to do is multiply these two numbers. So we have 7.5 times 3. So I'm putting my coefficients together, and then I'm putting my powers of 10 together. So let's go ahead and do 7.5 times 3, 22.5 times, and then I use my product rule for exponents, and I keep my base the same and add my exponents to the 6th power. So all I do is put it back in scientific notation, so it'll be 2.25 times 10 to the 7th power. And that's my answer here. All right, the speed of a garden snail is about 8.3 times 10 to the negative 6 miles per second. If a garden snail, I think I might have said a garden nail. If a garden snail moves at this speed in a straight line for 3.6 times 10 to the 3rd power seconds, how far would the snail travel? So again, you're just miles per second. Okay, so we're trying to figure out the number of miles. So what you'll do is, if you're given miles per second and I also give you seconds, we're just trying to find the miles. So all you'll need to do is divide this time. Okay, so what we'll do is the same thing. We're going to group our coefficients together and group our powers of 10 together. All right, so 8.3 divided by 3.6 times 10 to the negative 6 divided by 10 to the 3rd. So we go ahead and do 8.3. Yeah, 8.3 divided by 3.6. Okay, I definitely did that I did that the exact wrong way. So what you really need to do here, you don't need to divide. I read that wrong. You do need to multiply like we've been doing. I don't know why I thought that. So this is the amount per second, and this is the number of seconds. So you're literally just multiplying still. So 8.3 times 3.6 times 10 to the negative 6 times 10 to the 3rd. So you go ahead and multiply. So you have 8.3 times 3.6. You have your 18 and 49, 9 and 24. 8, 18, 9, and 2. And 2 digits behind our decimal. Times 10 to the negative 3rd. Because I know that I keep my, when I'm doing it here, I'm using the product rule. So I keep my base the same and add my exponents. And then I just need to put this in proper scientific notation. So my coefficient needs to be 2.988, and then I need to make this one bigger. So that's actually going to be 10 to the negative 2nd power. So here is my solution. And I apologize for making that mistake before. All right, and that is it for day 3.